Good evening, everybody.
Good evening, sir.
We are very much happy that today Dr. Ivan Das has accepted my request to teach on the binomial logistic regression tonight. And on Monday, he will teach about the multinomial model of regression. Dr. Das is a dedicated researcher in psychology with a specialization in psychology of sexual assault and women studies. With over 14 years of experience in the field of psychology, Dr. Das is currently working as a guest faculty at the Sidhu Kano Birsa University in West Bengal. He has worked as an ICSSR research assistant and was awarded the UGC NET degree in 2018. He has conducted significantly to research with his avid interest and specialization in statistical modeling in psychology. His expertise spans across various domains of psychology, including clinical, forensic, and applied psychology, and in areas such as economics, management, and excelling in time series analysis, principal component analysis, and statistical models across different science and social science disciplines. Dr. Das is also proficient in statistical tools such as Excel, SPSS, Python, and RStudio. His passion for research is reflected in his high impact factor publications in reputed journals like Elsevier, Springer, Taylor and Francis, and Sage, and also through has active participation in academic conferences and seminars. Beyond academia, Dr. Das enjoys writing, fitness, and exploring philosophy, reflecting his deep curiosity about human behavior and mental health. So now I am requesting Dr. Ivan Das to share the PPT, and I like to introduce you our student. Shubham is here. Shubham Pandey. Shubham Pandey is from BHU. Dr. Amit Tirpure. Amit Tirpure is from AIMS. And Muhammad Rafiur Rahman, he is from University of Dhaka. And Kavita Shahu, she is senior nurse from Kolkata. And you will get some more students later on. But now you can start your lecture.
All right. I would like to immensely thank sir for giving me the opportunity to speak to all of you, and that was a great introduction from your side, sir. And having said that, my namaste, my welcome to all of you, my hello to all of you. I want to begin the session by wishing all of you a very good evening, and I hope you have had a lot of classes here with sir, with other faculty members. They have had the opportunity to speak to you, and I believe that you will like today's presentation, and it will be an honor for me to share whatever I know regarding the topic of the uh, logistic regression analysis. Okay, so basically, let us now begin without any further ado. Okay, so it will not be any kind of presentation or this PPT slide as so far you may call. I would like to teach on this whiteboard. I would like to go by this blackboard approach. I want to write. I want to share things with you. I want to make sure that you remember things. Okay, the big fonts and the fixed things in the PPT, I believe it does no good because this is a very flexible area. Let us make a little bit flexible. Let us handwrite and hand draw, and let us learn things from, from this classical point of view. Sir, I think there is echo coming from your side. Is there
Mr.
any second?
Please mute your audio. It won't echo.
Yes, yes. Now it is okay. Now it is okay. All right. So let us learn about what is logistic regression analysis. Okay. Basically, you have learned about the multiple regression analysis or the simple linear regression, the multiple linear regression. I think you have learned about that. So basically, what we used to do in the simple or the multiple linear regression is that you have a y variable, that is the dv I'm writing over here, and then you would have the y-intercept, the slope, and then either one independent variable, or you could have multiple independent variables like b2 x2 would be there, b3 x3 would be there, and dot 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 up to bn xn would be there, right? So the nature of this multiple linear regression is that whatever, let me mark it off, whatever be it, be the y or the dv or the multiple x variables, they all had to be metric in nature, right? So talking from the point of view of the scale, it has to be on the equal interval scale or in the ratio scale, be the y variable, be the x1, x2, whatever you used to input them. Nominal variable were not allowed. The discrete variables were not allowed. You had gender, you could not put it here because how would you put it in? One or two, you had to dummy code it, and that is not allowed over here. That was the basic assumption of the regression that you could not bring over here. So in that case, we had only the opportunity to work on the metric variables. However, will will there be no mercy for us if we have one important nominal variable going on and I want to treat it as my dv, and then I want to regress it upon the different kind of metric variables. Suppose putting a y-intercept, maybe I have the x1, then dot 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 I have the x2, then dot 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 I have the x3, where the mixed features are there here. One may be metric, one may be nominal, another may be metric. So this kind of model, if I have, I need to go through the logistic regression analysis at that time. So the rule of the logistic regression analysis will be that the dv will have to be nominal variable. Always remember this thing. The dv or the y variable has to be the nominal variable. It can be gender, it can be age if you write it like minor, non-minor, adult, young, old, this kind of values. Okay, the income level like the lower class, the middle class, the upper class, these kind of nominal variables will be involved over here. And at the same time, you just, if you look at the right hand side of the equation, then you can have mixture. It can be all of the nominal, all of the ivs can be metric, or it can be a mixture of the metric and nominal, like I have shown in the screen. Like x1 I have written m, that is metric, x2 is nominal, and x3 is metric again. So this is the formula, this is the structure that you need to remember. So I hope I hope you have understood this so far, that what is the main points of distinction between a multiple or the simple linear regression and the logistic regression analysis, and when to use it. I hope you have understood that. Some yes from your side. I'm expecting.
Means, sir, in the linear regression, all are metric, whereas in logistic, the dependent variable is categorical.
Right. So when you talk about the simple or the multiple regression linear, like you said, all should be metric. However, in case of logistic, always remember the dv is not free to vary. The dv will have to be nominal and nominal only. And then you can move forward to the IV. They can be a mixture of both the nominal, or it can be only nominal, or it can be only metric. Whatever it may be, everything is allowed. Everything is accepted over here. So building upon this basic premise, I am basically proceeding with a little bit of the assumptions which I would like to mention. So one thing is that if I have the dv over here, which is nominal, not much of the, you know, this parametric statistics assumptions, much of them will not be here. However, it is important to learn some of the assumptions. We need to keep some of the assumptions in mind. So the first of all is that dB has to be measured on a dichotomous scale. If I go for the binomial, yes, now I must mention that now the logistic regression analysis is of two types: the binomial logit and the multinomial logit. This is the binomial logistic regression and the multinomial logistic regression. Very easy to understand. When is the BLR applied? This one, binomial applies when the y has two levels going on, only one and the two. Suppose you take gender. I mean, obviously, gender is an open spectrum kind of a variable. However, if I take it as a binomial variable, then it will be only male and only female, then it can come over here. However, if in gender you take the male, female, and the others, suppose 1, 2, and 3, then binomial model will not apply. At that time, multinomial model will apply: male, female, others. You can bring others also, like LGBTQIA plus. So all of the things will be there in the Y, which would suit in a MLR model, multinomial logistic regression model, because it has more than two values. I hope it is clear. So right now, I will be dealing with the BLR only, and the MLR is basically scheduled for Monday, as sir have mentioned. So let us talk about the BLR first. Okay, I would use the abbreviation BLR. It would be easy to say. Okay, binomial logistic regression. So let us read what are the basic assumptions of it. First of all, it has to be a variable with two levels. Okay, so it has to be two levels, like I have said, one and then two. Not more than two level will be allowed. Okay, obviously. Then there may be one or more independent variables, and whatever be it, it can be nominal all, it can be metric all, or it can be a mixture of the both. Now, moving ahead, we have spoken about the independent variable, and now it has to be mutually exclusive. This is one important criterion that you need to remember. The variables need to be mutually exclusive. Obviously, autocorrelation is not allowed upon there, because if they are not mutually exclusive, if their IVs are overlapping, I think you have learned these basic things about the simple and multiple linear regression portion only, that sort of the IVs need to be not correlated among one another, because if they are highly correlated with one another, then they would be treated as the same variable. So why are you then including it as x1, x2, x3 when they are the same thing? So like that also, here also it is applied, the logic is applied, that it is expected that you can have multiple IVs, no problem with that, x1, x2, x3, multiple IVs are welcome. However, you need to remember that they need to be mutually exclusive. If they are very much related or very much close to one another, it is basically it would be just to measure it up and just bring them all together and name it one single variable, right? So the mutually exclusive criterion is one of the major assumptions of the regression analysis that often researchers fail to understand and fail to basically check it also before they are running any kind of regression analysis, be it the multiple regression model, be it the logit model, whatever. Okay. So, and also there needs to be a linear relationship between the DBs and the IVs. Overall, a linear relationship is expected if you are looking for the significance of the results. If you want your research hypothesis to be accepted well, then it is very much important to understand that there should be an overall linear relationship. Overall, the variables should like go hand in hand with one another. So one linear relationship is always expected. This criterion you will see in case of the different kind of non-parametric statistics also. Okay, like you see in case of Spearman Spearman rank type correlation, which is there. Have you seen that there are also the assumptions are given, and under that it is also said that the pair should be dependent of other scores. Have you asked there why so? It is a non-parametric statistic. Why do they have the assumption? It is basically optional. If you are willing for good matrices out of it, acceptance of the p-value, okay, then it is expected the better the model it will be, the better results it will be yielded. Otherwise, no such stringency, because non-parametric statistics is distribution free statistics, as we know. So here also, even if you have the nominal variable, it is expected that you can draw some kind of linear relationship between the two. Okay. So having said that, let us now move towards a little bit of this theoretical portion. I will now talk about the AIC. And what is the full form of the AIC? The archaic information criterion is a very important thing to remember in case of the logistic regression and analysis model. The archaic, AKIK, information criterion. Please excuse my handwriting over here, and then criteria. So you can write the short form of it. It is basically AIC. Okay. What is the utility of the AIC now? Why is it used? Have you heard about AIC in the past when you were working on the simple linear regression or maybe the multiple linear regression? No, it is for the the nominal variables where the DV, where one of the major nominal variable is included in the model, and in the model nominal variable serves as a major role. At that time, the AIC will be basically used to assess the flexibility, assess the importance, assess the you know the importance or the strength of such a model which has a nominal variable on the emperor seat, which is sitting on a very important role. At that time, the model needs to be understood by AIC. Basically, AIC is not an inferential metric. What do I mean by it is not an inferential metric? You don't get any kind of p values out of it. It is just basically the descriptive assessment of two different models. Suppose you have model 1, suppose you have model 2. Okay. So if you need to assess that which model is working better than the other one, the AIC which can be brought from the two models can be assessed, and you have to look for which one is lower. I am entering into the practical part. Let me talk about the theoretical part a bit. So basically, how much information, relative information, the model is holding, or how much relative information the model is losing, that is an explanation of the AIC, very much related to the variance explained by the model. These are all matrices. Um, these are all matrices of sir, I think you can mute. You can just basically shut off the screen. Um, Okay, so the thing that I was saying, that basically it assesses the strength of the model. All right. So AIC is the relative amount of information retained or lost by the model, finally explaining the strength of the model. So it is basically brought forward by this goodness of fit indices that you have read in case of this non-parametric estimates, right? Chi-square and all brought the goodness of fit in indices, and from that all only it is very related to that. It is also a non-parametric approach to understand which model is doing better. Suppose if you want to find out the AIC, you can run it in SPSS. It would be better, statistically more powerful output you can get in case of the multivariate analysis. If you have many variables going on, I will show you how to do it in SPSS, but I would recommend that if you have many variables going on, no, please go for the R or this Python. It would be better and more accurate estimate of the AIC. Anyways, so the AIC formula I will be mentioning to you. So the AIC equation is basically given as -2 into log of likelihood plus 2k. Okay. So these are the this is the formula, this is the equation by which the software basically assesses the AIC. You don't need to go into the math part much because we're not doing hand in hand, but still for your reference, I have given you the value. The K are the number of the predictors going on. So like this, you are working with the AIC, all right? So suppose if you run AIC and AIC is giving you the values AIC1 for the first model, it is 512, and AIC for the second model is 250. Always go for the lesser one, because it is the amount of information lost. AIC is basically giving you the amount of information lost. So two models for that, I have AIC1 and AIC2. Go for the lower one. Why? Because it tells you how much amount lost. It is 250, which is comparatively lower than 512. So it is better that you go for the AIC2 one. Okay. So AIC will basically help you choose between multiple models. Suppose I have some variables going on, and that is, suppose basically the first part of my research, that is my model one. Suppose I have the total n size of my research of 1000. So first 500 data, with this I want to draw one model. The latter 500 data that I have, with that I want to run another model. So which one would be better? My assumption is that since I have done the field work from the same universe, I have extracted the sample. It is expected to be the same, expected working in a similar fashion. Now, if I run the model, it is also expected that the AIC will be more or less nearby. However, the second model suppose shows to 250, then I will clearly go by the 250 with an understanding that there is discrepancy going on. Either some problem is on the first chunk, the first model, I mean the first 500 data that I have basically collected, or the problem may be on the second model. And what is the problem that I will have to practically assess and make it correct? So far, is it okay? How the AIC helps you choose between the model? Everybody?
How we will come to the fact that there are two models? How we will achieve that?
That is your basically this preliminary uh, understanding and this preliminary iteration. Often you have multiple models going on. Suppose in your research work you did a lot of literature review, and from that you are basically unable to understand which ones to choose. You have data for all of them, secondary kind of data you have taken. So literature review shows the strong significance of all the 100 variables. In the first one you take the first 50, or randomly you take 50 and the other 50 will be left on another model. So that is where you get the need to check which one model should I choose. It does not happen usually, because in research work it is very difficult to get data and information from one model only. But by chance, if you want to tally, suppose the literature reviews model ke sath you want to tally your model, so if the variables are going nearby same, then you can match and check which ones is better, provided you have all of the data and information of both. So in the case when you have to choose between multiple models, go by the AIC. It will help you choose the model properly. AIC's application can be found in, I don't know how many of you from economics management. Time series analysis also utilizes the AIC BIC model. They also use it. So who asked me the inquiry? I hope, is it clear now?
Yes, yes. I hope with some examples we can get
Sir,
in.
sir, can
Yes.
you just explain what is the meaning of model?
The meaning of a model, right? Okay. So a multivariate model is, suppose you can take anything can be a model, Suppose you take the example of a home, whoever be the head of the family that is sitting on this pivotal position, and the other people are also helping that person to run the family so that it goes good for everybody, one of them. So for everyone. So this is the model setting, this is the model environment where everybody is working hand in hand upon a certain goal, certain mutual goal. Here also, if you do the ANOVA also, there also the basically the linear modeling begins from the ANOVA modeling, right? From the GLM, we basically promote to the regression and all, and so the regression family statistics comes. So at least this multivariate approach should be there, where one or more variables is having an important position. It can be the DB. Okay, most of the times it is the DB, or maybe certain DB it is there. And for that, the other different kind of IVs are basically trying to, predict or assess how much different they are from one and another. This kind of mutual goal is being settled in this multivariate environment, and this is known as a model. Now, one more thing I would like to add, the unique feature of the model is the model itself works like a unique personality. One person in the family may be very much naughty and very much, they are having foul thoughts in their mind, always trying to damage others. Second person is also like that, and the third person is also average. However, when everybody comes in a model and looks at their objective and how they work all together, it can be for a good cause. So individual personality may or may not merge with the personality of the model. Model, whenever a model works, it creates a unique personality of its own. This is the beauty of a model, from where the concept of latent variable also comes. In structural equation modeling, in factor analysis, I hope you know, the latent variable also basically comes. What is that? So the latent variable is basically sitting with all of its offspring, the different elements that are falling, the observed variable. So that is a unique model. Now, multiple unique models bring up the entire factor analytic model. So this is how unique personalities are brought up whenever we are working with the model. Is it now clear, sir?
Yes, sir. But I think along with the more examples, I will understand. You have given a very better explanation there. Thank you.
From the real life point of view, I have said to you, when we have
Yes, yes,
more
sir.
time, otherwise you please give me a call to take the number from sir. I will give you ample examples, because it will take time to tell about the variables, multivariate approach it is. So you take the time to give me a call. I will make sure you understand how model basically works in the real world and in the statistical world. Always try to draw inferences from the real world, otherwise statistics will never be
That is
used.
what I want, sir.
Always
Sir,
draw
here
inference.
you have explained the formula. So
Hmm.
here, what is the model there, or what AIC is doing here?
AIC is basically taking into account all the variables that are there, the DVs and the IVs. I will show you shortly. I will show you shortly. It will take into account all the multiple things, and from that they will try to bring out that whether the entire model, which is basically having the different DVs and the IVs, how they are working in a mode, how they are working all together. Okay, this is
So
something that
AIC is like a goodness of fit indices, right? Is that so, Ivan?
one of a kind, you can say, not exactly the goodness of it, because there are other semantic elements to it also. If it
Okay,
is
okay.
only the goodness of it, then I could have gone for the goodness of it.
Okay, okay. Got it.
So it also involves something else like the nominal variable approach. So this kind of unique things, some added things are also there into the
Okay,
model that is dealt by the AI.
okay, okay.
However, you are not at all wrong when you said that they are most probably then going hand in hand and looking towards the same page. Obviously, they are. Okay, so I will change my screen now and I'll go to SPSS and I'll show you. So I am sharing my entire screen with you right now. Okay, so you see whatever I am doing. Since I have talked to you regarding the AIC, I will take less amount of time to make you understand how to find it out in the SPSS. Okay, so you see here I have taken certain kind of fictional kind of a data and information, and I'll try to work with it. Okay, so how to find out the AIC? Let us go. You have to go to the analyze, generalized linear model and generalized linear models. Write down the trail. You can write down the trail. Okay, so I can basically click on that. I believe this is being recorded, and later on in the YouTube also you can check. Okay? So
Yes.
basically you have to go to these predictors. Okay, so what are the different kind of predictors? Suppose I will take the RM, RS. Okay, 60, the desire to have sex. This is one of variables in my PhD work. Okay, so the loneliness, you involve it upon here. Okay, you just basically have to click on here, covariate. Okay, it has basically brought here. So you please go to the model. So originally it will be showing like this. So IRMS, ARSQ, SDI, UCLA. Bring it up on here in the model. Okay. Okay. In the response, you need to put the DV. Okay. So I had missed. First of all, I could have basically come here in the response. So in the response, suppose I want to put any one variable as my DV. Okay. So I want to put the element. So I want element to be predicted by the other independent variables. So element is my DB. Let us put it here. Then you come to these predictors, whatever predictors you have. I have moved it in this section. I hope you understood. In the model, the factors, whatever they are, IRMS, ARS, you select all of them and move it here so that they can understand that these are in the model. Now, please come to the estimation, nothing to click. Statistics also nothing to click. Just you just have to check over here. The goodness of fit statistics are there and all of these ticks are here. Now, please press on OK. Now, while you click on OK, you will see that the values will be here. Here, you see under the GOF, under this option, under the GOF option, you can see that the archaic information criteria and the AIC is there. Understood, everybody? Is it clear?
Yes, noted.
So this way you can find out the AIC. So the value of AIC is here. Now, like I said, if you want to interpret it, there is no such metric that it has to be above 100, below 200, no such metric is there. It is just a number, non-inferential metric. This will help you to assess and choose between models, different models of multiple, not this multiple linear regression, sorry, of this logistic regression model. So which one is higher, that will be excluded. For the different models, the different AIC you have, the higher please exclude, the lower please retain. That is the model that will give you better health of the results that you are expecting out of it. Okay. So like this you can work on. Okay. Suppose I want to find out how much, you know, two nominal variables, attendance in an office is related to gender. Suppose I want to find this out. Now, attendance and gender, I have two models. Suppose I have two businesses. One is my school business, another is my university. So in model one, attendance and gender will be basically put into a logistic regression analysis model, and also for the second one also. So I want to check, though the variables are same, the variables are the same, attendance, gender, for school, for university. I want to check which model is a better fit, which model is working much better. So I will find out the two-way AIC, and then I will choose whichever is lower one. So if I see that the university is doing good, then in university that means that the attendance will be related to the gender of the employees in a much better fashion, in a much accurate fashion. The IV is predicting the DV, as you could say in case of the school, because there maybe some other factors are there which are basically predicting what gender people will be, and it's not on the basis of the attendance only. Understood? So people can be discriminated between male and female based on other factors also, but very weakly on the basis of the attendance. So like this, you make a very good kind of a decision and you choose which model I should take up and I should proceed. If you are working and then if you have any kind of government projects and all, this kind of decision making, model decision making will help you a lot. Okay. Is it clear now? The example that I just shared with you, sir, now? Is it clear?
Yes, clear to me.
Okay. All right. Now let us. Yes.
However, I just want to confirm one thing. So when we are going to analyze, and we are deciding for our model. So there it was written factors and covariates. So whatever the independent variables will be treated as factors and covariates.
Whatever the nominal variables, whatever be it, you have to bring it here. Okay. Nominal
Okay.
metric, whatever. The entire chunk should be here.
Okay,
So,
and the build term option that is there in between regarding it's talking about the main effect. If you can just go to that, yes. So here the dependent variable will be there. When you press on the model, just press on the model.
yes.
So here the build term is
Main
yeah,
effect, it will be retained. It will be
okay.
retained.
It will be
Don't
main
touch.
effect only.
Don't touch. It will be
Okay.
there by default. It is main effect. You don't need to alter it anyhow. There are many kind of things are there, all two-way, all three-way. You don't need to go there. Okay? Just
We'll
like
keep
that.
it we'll keep the main effects, and
Main effect.
all the
Main effect.
independent variables that are there we'll put it in the model form, model
Right,
section.
right.
Okay.
Whatever will appear over here, just move it here. So I have talked about response, move it here. These predictors, move it here. Model, move it on the right side, and nothing else to click because other things will be left intact. Whatever is there, click on OK. The result will be in front of your
So
eyes.
in
Okay?
model, all of our variables will be put in model, right?
Everything. Because in
Everything.
the model, whatever will come, see the DV is not here. The
Okay.
IVs and all will be here. Okay.
Okay. Okay.
So whatever it was there, it will be.
And in the predictors, how come the predictors and model section is different?
This is how the SPSS runs because you are trying
Okay.
to run which kind of a model. I mean, you could choose the main effect, the interaction
Okay.
effect.
Okay. Okay. Here we are deciding which kind of a model we want.
Right, right.
Okay.
So
Got it.
here also people may basically choose not to bring some over here, though everything has been put in the predictor.
Okay.
People may choose only to bring this two because that also brings in the importance of the effectors. So
Fine.
suppose
Fine.
you are prioritizing on some one or two, you bring it over here. Okay.
Got it.
So
Got it.
while they check the health of the model, something the predictor shows that I'm willing to work a regression on this variable.
Hmm.
And model means you please show me the health based on these variables. The other I am willing to remove. If I see problem, I can remove. So you
Okay.
put into priority these ones. This is what the model says. Okay.
Okay.
And then the type, the main effect is there, and the other ones are also there. Okay. Like
Okay.
like suppose you are going to a zoo garden and the child's fare is free. The main point of view are the adults.
Yes.
So the child goes in there, has some ride, has some food, does not matter much. So the child is basically a free thing that the amusement park sees like that. Okay. So the
Okay.
same analogy will apply over here a little bit.
Hmm.
Okay.
Thank you. Thank
So
you.
welcome. So here now you please check. I will try to predict ailment. Ailment means any kind of physical ailment. I put it in the format of yes or no. I will change the view value label. You see no, 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 and then yes, 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 yes. Below it is there. Okay. It is a large kind of data because it took time for me to build this fictional one, because otherwise if you don't have large kind of a data going on, no, they will not be significant enough, so I will not be able to show you. Still not everything will be significant because manipulation does not give you what you want. So anyways, and the other honest ones that I have drawn, those have unfortunately been of small size, and that is why they have been insignificant. So that is why I had to work on a little bit fictional kind of a data so that I can show you. Okay, being very honest with you. Okay. So now you see the ailment is the one that you will need to predict. So it is your DV. And what are the other variables that you need to predict? Let us put a mixed approach. I will take, suppose, the age. Age will be first IV, then IRMS, ARSQ, SDI, UCLA. Okay. These are the variables which will try to predict ailment. Understood? So here you see it is a mixture of the nominal variable, and it is a also having the metric variables. So the metric variables are IRMS, ARSQ, SDI, UCLA, and the nominal variable is age. Now let us move forward. Analyze. Suppose I'm trying to predict the ailment, then what to do? Analyze, regression, then you click on binary logistics. Okay, binary logistic regression, you have to click. Please write down the trail or you can follow it later on. So here you can see that first of all, my dependent variable will be which one? Ailment. Okay. So please understand that age has three layers and various kind of levels are there. Okay. It is having different kind of variables. Suppose sub variables are there. Suppose the values are, you can check. These are the values. I will go to the variable view to show you. These are the one. Okay, so 1, 2, and 3. Is it visible? So three separate kind of age ranges I have basically taken over here. Is it clear, everybody? So now let's check. I will just basically go to analyze, then regression, then the binary logistic one. Element will be put over here, and like that into whatever variables will be my IV, the IVs will go in the block one, similar to the simple regression and the multiple regression analysis that we have done, So like that one. So let us age goes first, then goes RM, RA, 6D, and loneliness. This variable also goes in. Is it clear so far?
Yes.
Categorical variable, here you need to choose. Why is this tab? Because this tab will make you understand whether the software will need to understand whether there is any nominal variable going on or not. Here, whatever IVs I have taken, definitely I have one nominal variable going on. So I need to mention him that SPSS, look, the age is my nominal variable. So this is how you are mentioning it here. Okay. I hope you know about the figure and ground relationship in psychology. If you are not from psychology background, let me speak to you regarding one example. Suppose you are trying to click a picture of yourself. Always you need to put a background. All right. So two different types are there, two different values are there, suppose male and female. The answer will come in this way, that is whether men are doing better than female or the female are doing better than the male. So a reference category is there. Which one you are basically comparing in the lights of what? So that is what I will now let the software understand, that I can maybe take the first one. I mean, the number one that I had shown you, 18 to 23. So I want to put it in the background on this area while the first one is lying on the background. I need to check how the others one are doing as respect to it. Okay. So it will be like 1 versus 2, 1 versus 3. 1 lies at the background. First 2 will be tallied with 1 and checked who is doing better, who is doing higher. And second, number 3 will also be tallied on the background with A and will be checked who is doing better or who is doing worse. Is it clear?
Yes, but when it is 1, 2, 3, then it is
Hmm.
multinomial, right?
Yes, but I have to put one thing at the background. You can put only one thing on the background. The
Okay.
other two values will just follow with respect to the one.
Okay.
So I have put the first one in the background. You could choose the last one also, no issues with that. I am taking the first one for your ease of understanding, because the first one, as you remember, is 18 to 23. Okay, now let us go forward. So, okay. So as you see, you have to click on
But
the
why
first
you are
and then you
mentioning
have
that?
to, yes,
No,
yes,
clear,
please.
clear. So here, uh, okay, fine. Fine.
Ask me, no, ask me. Ask
Can
me,
you
no.
just go back a step? Uh, just close this.
Hmm.
Okay, age is also our independent variable, which is categorical
Obvious.
in nature,
Yes,
and now you are defining it.
right, right.
So in the binary logistic regression,
Hmm.
we are having independent variables, not only scale variable but a categorical variable as well, and you are defining it as well.
Like mentioned earlier in the beginning of the
Okay,
class, it is my objective to show you a mixed approach. So
okay,
let us bring everything so that it becomes very much clear altogether. So
okay.
here you see I had checked on the first, but I forgot to click on change. It will not work. So you have to click on first, then click on change. Whatever you click on, last or the first. So after you click it, click on change, because then it will move here. See, now it is writing indicator in bracket first. Now it has been registered. So click on first and then click on change. It will then register. Then click on please continue. Okay, done. Options, please go to options. Here also you can see these values will be blank. Okay, this is how it will be presented to you. So the classification of plot, click it. The Hosmer Lemeshow goodness of fit, this will be bringing you this chi-square value. All right, and then This case-wise listing of individual residuals are not basically required, but still anyways, I'll just click on it. Also remember to click on the CI for EXP. Maybe the tick was given over there. I will remove it and show you. You have to click on the CI for EXP. Okay. So these four areas, please write it down. Classification plot, the HLGOF test, and the case-wise listing residual, and then on the CI. As you know, for APA presentation of this table, it is mandatory to show the CI values, upper 95%, lower 95%. I hope you have learned about these things. So click on the CI for EXPP. Okay, done. Let us now click on OK. Then nothing else. You don't need to click on anywhere else. It is done. No style, no bootstrap, no save, nothing. You don't need to click on anything. Just click on OK. Is the screen visible? The result has appeared on the screen. You can see it.
Yes.
Okay. So from the beginning, I will say the case processing summary. You know a lot of miscellaneous stuff SPSS gives you. No need to focus on that. Dependent variable encoding. No was 0. Yes was 1. Accordingly, so here no 0 yes 1 means ailment. Remember my DB. So I said no ailment and then yes element. So no was 0, yes was 1, just revising what I inputted. After that, you see the variable encodings are given over here. See what was my reference type? 18 to 23 was my reference. So you see it is 0, 0 because results will come on the light of this first one, 18 to 23 age range. Okay. However, the second one you see that is given 1 is given over here. That means 24 to 29 will call parameter 1, and then 30 to 35 the marking is here. That means it will be called 2. Okay, is it clear? See, software will mention age 1 by this 24 to 29, and the 30 to 35 the software will give you by age 2. Is it clear? Because beside this
Not clear.
24 to
How can
20,
we, how to, I understood that age has been categorized into three categories,
Hmm.
different ranges 18, 23, 24, 20, and 30, 35. And then while processing ahead, we clicked 18 to 23 as first. So now how the result is coming, please elaborate a bit more on this.
okay, wait. You please take the 0 as no marking and the 1 as the one kind of tick or check. Okay, now you please see over here. You take 1 as a tick and you take here also 1 as a tick. So age 24 to 29 will be 1 because a tick is over here, and 30 to 35 will be regarded as 2. So this is 1 in SPSS language, this is 2. This one we will not talk about
Okay.
because this is the reference one. So on the light of 18 to
Okay.
23, we will see how 1 is doing, that is 24 to 29 is doing. And on the light of 18 to 23 years, we will check how that number 2 is doing, that is 30 to 35 years. This 1.0 is basically one mark. This is tick. Take 1.0 as a tick, 0 as no tick. Now is it clear?
Yes.
Software will say age 1. What does it mean? 24 to 29. Software will say age 2. What does it mean? 30 to 35. Everybody clear? Other than Mr. Pandey? Dr. Pandey, right? Doctor or Mr. Pandey?
No, sir. I'm still a research scholar.
Okay, okay. All right. Everybody else understood other than Mr. Pandey? Okay, let us then proceed. So, how SPSS will be regarding, that is clear. This classification table, you don't need to note much. You can just have an eye over it. You don't get much of information from it. Please proceed. Then you can just ignore all of these things. Only note whatever I am basically asking you to note. Okay. So I told you to note this one. Okay. Variable encoding, nominal variable encoding. This one you have noted. Then you move on towards this one, the summary of the model. You know what the summary of the model is? This is this one, this n r square you will take. Nagelkerk or the NR square. This is basically a pseudo R square. Always remember. Nagelkerk NR square is basically a pseudo R square. Why? Because it is a non-parametric model. The DB is non-parametric. How can you expect a absolute R square? Okay, it is a pseudo R square. So forcefully we are trying to bring out the variance explained in the model in a pseudo fashion. That is why the Nagelkerk R square will be used. Okay. Now you see Nagelkerk R square is showing to be 52.9%. Not very bad, above average. I mean just above the average value of 0.5. So 52.9%, that is means 53%. We can proceed, no issue. Next, note down the Hosmer and Lemichaud test. Remember, Hosmer and Lemichaud test will basically give you this chi-square value. Okay, you have to check whether the
What is
p-value
this
is
Cox and Snell?
Cox and Snell R square is another R
Cox and
square.
Snell R square.
However, the type 1 error chance is quite high over there. It is a little bit stringent. Okay, so we don't go by
Okay.
this one. Okay, sorry, I'm talking about this
So this
type 2 error. Sorry,
Cox
it
and
really
Snell R square.
yes. That is why you see it is low. Okay, so it will be
Yes.
more stringent.
Okay.
It will be more stringent to work with the Cox and the Snell. If that is good, if you want to report that, very good. I mean, the weight is very much recommended, but the minimum criterion is you at least look
Okay.
at the Nagelkerk R square. That will give you a little bit of relaxation. Otherwise, it becomes too stringent. See, you cannot report the
Okay.
39% usually. Usually you
Yes. Yes.
cannot
It's very low.
report that.
Yes. Yes.
So
Very
you
low.
go by the Nagelkerk.
Okay.
Just like you remember, just like in the normality testing, you had the Shapiro-Wilks test, right?
Yes. Yes. Saprovilk
Case
and
test,
Kolmogorov.
yes. So the case test you did not go. You used to take the Shapiro-Wilks because case is a little bit more stringent. No need to make it more stringent, right? That is why you took the
Okay.
this
Okay. Fine.
Shapiro-Wilks. Similar to that only here also you are doing.
Like,
Okay. This chi-square that you
okay.
have, this was supposed to be significant. Remember, because this is a fictional kind of a data out of which I am giving you a learning experience, it came out to be insignificant. If it is not significant, it is recommended not to proceed with it. Remember, in regression, it had ANOVA. So ANOVA was what? It was a matrices of how the model was working. Here also the chi-square, because it is a non-parametric approach, the chi-square will be the model fit here. So here also it is showing that it is not a very good fit. Remember, so the p-value is found to be quite high. So usually in this case, I would not proceed to interpret. I would check on the variables, check on the sample, maybe draw more sample. Okay, maybe recheck into the outliers. So then you could refine the model and make sure the chi-square would be significant, at least less than 0.05, and then you could proceed. But please excuse with me, we are having a learning demonstration over here. So though the p-value is not significant, I would just proceed to make you learn what to do on the next part. Okay. So
Sure. Sure.
assuming it is significant, I will move forward. The classification table and all these things are not required. So move swiftly towards the variable in the equation. This is the last table that we will stop. The next one here, the different kind of graphical presentation, the case wise not required. We will stop over here. This is the last one. Okay. So how to interpret this one now? Let us take it on the bigger screen and understand. Everybody, please pay more attention now. This one is the very main estimates of the logistic regression analysis.
Yes.
So basically, what you had beta value to make you understand better. What you have beta, that is here world. Okay, this world. Okay, this EXPB, this is what the odds ratio OR. The EXPB is basically the odds ratio. Okay, so it is the exponential. It is the exponential value of B. It is exponentially elevated version of the B. There is formula of the EXPB. So we are not going to the math part. So the EXPB is derived from the B, and also world is also involved into it. So the EXPB is the odds ratio. Now, how to interpret the entire thing? B, you know, B is basically is related to the slope. Okay, B is basically very much related to the slope. AC is the standard error. DF2 you know, P value you know, this definitely you know, right? So now I have also said the world is
Yes.
parallel to the beta over here. Now let us check how to interpret. See, age 1, age 2 दिया हुआ है यहाँ पे. So you remember I said software will say age 1. What does that mean? That one, right? And also the last one, the highest
Yes.
age
Yes.
range one, that is age 2. Now age 1 will be compared on the lights of 18 to 23. That is the first one. So you see how it is done here. First of all, number one step. First of all is check the P value. First of all, you have to check the P value. Which one's P value is not significant, do not interpret that. I mean, you can write down. I mean, they are not significant, that only you will write down. It is not your point of interest, right? Here, your point of interest will be only the ones that are significant, at least at 5% significant level. So you are moving forward to, the age. Both the age is luckily doing good, you see. Though nominal, they are doing good. RM, however, is a metric variable. See in the model, they are not working well. RS, not working well. However, sexual desire, this one, 0.012, it is working well. Okay, lawn again is not working very well. So you see, it's a mixed result of the insignificant and significant, which I intended to show you in this example. So how to interpret it? Age 1 is, remember, because it is significant in nature, also note what is the direction of the world. Okay, sorry, direction of this beta. Check the direction of this beta. This can be plus, this can be minus. You see, RM is minus. Okay, so it can be plus, it can be minus. You take the direction from the beta. You have to first of all validate that everything is significant. Then you can take the direction from the beta and then move on to the EXPB here. Age 1 is 3.47 times more likely to have yes element. Listen to what I say again. Age 1 with respect to age 0, I mean the original age type, reference age type, is 3.47 times more likely to have any kind of bodily ailment or ailment, yes. Okay, listen to the example, then you will just try to answer and ask different questions. Age 2 is significant and it is 63 point something times more likely to have ailment, yes, that is more likely to have any kind of bodily ailment. RM is not significant, so I am not interpreting it in this fashion. RS is not significant, I am not interpreting it in this fashion, not required. However, 6D is basically significant. So 6D is 1.9 times likely to be directly related to yes ailment. So which means higher the 6D, higher will be the ailment yes. So remember how I am doing. Remember the interpretation style. Learn it very hard. I am checking the p value. Whatever is validated by the p value, I will interpret them. So regarding that, I'm saying like this. I will take the sign from the beta. So beta, not beta, sorry, B. I'll take the sign from the big B. So if it is plus, it is more likely to be related directly with the DB. So which is why I am saying age 1 is 3.47 times more likely to be related to yes ailment. Why I am saying more likely to be? Because B is positive. If it was negative, I would say age 1 is 3.47 times less likely than the reference age to be linked with yes element or having yes element. Okay. Again, H2, I'm saying H2 is 63.27 times more likely than the reference H to be linked with yes element. Okay. Now, if I talk about sex D, that is also sex D higher the sex D, because you see the B is positive. It will always be higher the sex D, higher will be the yes element. So sex D, higher the sex D is, the higher will be the yes element by how much intensity? By 1.009 intensity. Okay, there is 1.009 odds that higher the sex D, higher will be the yes element. Now you see, understood? Now please ask different question.
Okay. So first is how to so if you can see the 95% confidence interval for EXPB,
Hmm.
all it is showing all are significant. As per my understanding goes, if there is no zero in between lower and upper confidence interval, the value is significant.
Hmm.
So considering that EXPB, all the values are significant, isn't it?
Basically, you don't need to interpret like this here. You need to go
Okay.
by the p value over here. You
Okay.
go by the p value approach, because in this case, because it is a nominal way, right?
Okay.
And it is better not to interpret by the 95% CI, because you need to cross check it with the R also, because often in SPSS this 95% CI na, I have seen it has come out to be sometimes erroneous also.
Okay.
So it is better you don't go by the 95% CI approach. Though it is true, you can argue that whatever result I am seeing in the p value, it will be reflected in the CI, right? Table value approach will also see the show the exact same thing. There will be no distinction in the verdict of the hypothesis. They are just two or three sides of the same coin. However, here it is recommended not to check it. It is recommended only you report it in the APS style, and you please focus on the p values, because many a times it has found to be erroneous here in SPSS as well. Okay, it is better, that is why I am saying you go by the R for the 95% CI, you go by the R. Okay.
Okay. And
So
and how to interpret this word statistic beta? I mean, how we can you know uh,
see the
interpret it?
beta, see the beta is just the strength of the relationship. Okay, it is what is the standardized estimate. Beta is basically the standardized estimate, right?
Mm-hmm.
So it is basically here in if you remember, in case of multiple linear regression, it
Mm-hmm.
was this times related to that. We used to tell it with reference to beta value only.
Yes, yes.
Here, that power I have given to EXPB. World will be only remaining for the writing down in APS style interpretation of this table. Okay. EXPB already includes the notion of big B and world only. So it is better to go for the EXPB. So world, the utility of world here to give the value of EXPB, okay, or validating the EXPB.
Okay,
Understood?
okay.
And
Okay, got it.
also one obvious thing is that world's objective is what? Bringing the p value.
Okay,
The p value comes on the respect of the world.
okay.
So if no world, no p value would be there. So the utility of world or the pseudo beta here is limited. You go by the EXPB only, you check the p value. So once again, I am saying whether it is more likely to be related or less likely to be related, you grab it from the B, the big B. Because EXPB is exponentially magnified, no, it will always come positive. It does not come negative. Anything square comes positive. I'm sorry, negative, no. So EXPB will not give you the direction. Check the B value for that, the big B one. Okay. So if big B is showing you positive, that means more likely or less likely. Now it is how you interpret the odds ratio. Again, I am saying, suppose RM. RM is a metric variable, right? So it is 0.990 times less likely to be associated with the DB, that is yes element. I mean, higher the yes element, the lesser is the RM. To what extent? To what magnitude? 0.99 magnitude. Again, I can also say it reversingly that higher the RM, the lesser will be the yes element, which means no element. You can also interpret it like this, that if it is less related to yes element, then it is directly related to low element, which means here also adversingly you can write down that higher the RM, the higher will be the no element or the absence of any kind of element. To what magnitude? 0.99 magnitude. Now understood everybody how to interpret. Again, the age one, again I am saying, please remember, age one, because it is a nominal variable, it has a father at the background. The son will be compared with the father, not in case of the metric variables. We were just saying directly related on. However, in case of the nominal variable, we need to say like this, age one is 3.47 times more likely than the age reference to be linked with yes element. Mr. Pandey understood. Everybody else understood.
Yes, yes, got it. So, while we are interpreting, why we are keeping only yes element as the preference, not no element? I mean, if by any chance you mentioned earlier, I forgot.
Yes, because in that one, I will take you to the SPSS data. Here, I have put the the element here. Here in the element,
Mhm.
you see, one is the no element. However, two is the higher one is the yes element, right?
Okay,
So we will the reference is on the higher side only. Okay, you
okay,
design it like that only. If you reverse this code, the B score will have a minus in the front, meaning ultimately the same thing. So
okay,
it is
okay. So,
always better to go by the latter one. Okay.
okay, so the reference of when it comes to the explanation part, we are making the higher value that we have assigned to our DV.
Right,
We are referring with that in that sense, right?
right, right.
Okay. That is why
Because
you
it
are
will
mentioning always yes element.
right. The higher one is regressing to the IV, the higher one. We're not talking with respect to the lower side, that is the no element. That is why intentionally I put one is no and two is yes element. Okay.
Okay.
The higher one will be brought into light over here. Always remember that. So anybody else, any doubt from your side? Other names I must mention, Mohammad Rafiur Rahman sir. কোনো রকম ডাউট থাকলে বলবেন। Okay, and Amit sir also, Farha and Famida, Tofel, and everybody else. Amit sir also. Any doubt from your side, sir and ma'am? Okay.
I have one
So
last
sir,
question, so I'll answer at
Thank
the
you,
end.
Dr. Ivan. Very nicely, you have covered all the key points of the logistic regression. In logistic regression, the SPSS, this is the enter method, and there is some stepwise method. So, can you share? Is it possible?
yes. It is basically possible to show it. I will go by the same option. The
Also,
regression.
so just one last question. So, speaking of this logistic regression, before that, we have to compute any point biserial or biserial correlation. Is it a mandatory aspect?
You can do it. You may do it. However, you know, it will. I don't think it will be very much fruitful over here because, as you know, when multiple variables are there, it is better to rely on this partial and this multiple correlation. It is not good to check on the product movement correlation or the one-to-one. It is very much related to product movement, no? The
Yes,
bivariate
yes.
approach.
Okay,
Phi and the no, sorry, not phi, the point biserial, Spearman, product movement, they are all the bivariate correlation.
okay,
However, whenever you are having a multivariate model, It is better to go for the multivariate correlation approach. Again, the problem lies. Multivariate correlation, I mean the multiple correlation is very much strictly, parametric in nature. Here you are having the non-parametric, so it will not be fruitful. That is my opinion right now.
So as per the basic reasoning, I mean, we go for regression only when the correlation is established.
Right.
So, so if in this case we are going ahead with multiple IVs and one DV, what correlation analysis you would suggest me to go to?
Chi-square you have to check. You have to
I
check
square.
the multivariate chi-square. That is the LM test. That
Acha,
one
acha,
that I
okay,
was
okay,
showing.
okay, okay.
That will
So,
only be the model fit. So everything is given. The entire package is given. Here you
okay,
don't need to check. You check the
okay, okay.
AIC if you have multiple model, the Hosmer and the Lebesgue test. Okay, the
Yes, yes.
chi-square is if it is not significant, don't proceed. Okay.
Okay, fine.
So
So this H and L test will be our benchmark test. If it is not significant, we should not proceed ahead with the logistic regression.
right, right.
Okay,
You
sir.
should not
Thank you.
proceed. You
Thank.
theoretically, so you should not proceed. Then
Okay.
that means you need to check on the other kind of data, which one is working good, which one is working bad. You check it, then it will be okay. All right.
Okay. Okay. Thank
So,
you. Got it.
so you can enter upon the forward or the backward or world. Okay. Method is forward insertion. Stepwise method. If you go by the forward insertion, then it will be giving you, forward model one after one other. It will check one after another. It will be go on including just like the stepwise regression you have done. So let us check how it works over here. So you see step one and this step two they have drawn. You see it's basically the same way you interpret the multiple linear regression, sir. Same thing. In the step one, they have inserted age one, age two only. In the second one, age one, age two, and sex is included. The other ones have been removed because they are not doing well in the model. Okay, variables not in the equation. That estimate is given over here. The accounts is given. Which one is removed? Okay, so these variables are not functioning well. So they have been removed in my case. So whatever is accepted, they have been entered into two steps. The first step included the nominal variable of age. Uska age one and age two is given over here. And in the second step, age one, age two, and 6D is given over here. Now you can clearly work on it. Okay. So for that also, if you go,
Dr. Ivan,
Hmm.
the delta R square, which usually we find in case of the stepwise multiple regression, that is not available here.
Available, sir. However, in the version of Nagelkar R square, the pseudo R square, you can check the increase. You just have to do the minus over here and find out how much increase, how much increment in the R square is there. 0.006. Okay. First
Okay.
model was showing 0.0519. Second model is showing 0.525. So it is better to go by the second one. Also, the chi-square, the model's health will also be given over here. Hosmer and Lebesgue test. Here also it is being showing that significant one is absolutely 1.0. Completely utter non-significant result. Do not go by that. If you include second variable that is 6D, the model is improving much. So from p-value of 1, it is going down to 0.749. But unfortunately, again, that one is insignificant as well.
So
If
the
additional, yes,
second model's AIC value must be lower, right, sir?
you that was just I was about to mention. If you need any further verification, you can go and check the AIC. The also what picture you are seeing here that will be basically matched on the AIC version as well. Right, you are, sir. The second one will show is expected to show the lesser AIC. Okay. So because number two will be lesser AIC, go and accept that second one because it is functioning much better than the first one. Okay. So the same thing, you have multiple values. If there were three models extracted, then there will be three model summary, three Nagelkar square, and three Hoffman-Lebesgue test, and three models here also overall. So now you check which one to follow. Usually the last one in the forward approach is the better one to use. In the backward also you can check, this is your homework. You can put the backward also and you can check how the software is including all the variables as a chunk, and one by one they are going on removing. They will include all first, and then for the one after another they will remove. So backward that one is. So that will yield different kind of result. So you can explore it at your home level. If there is any problem, I will listen to you on Monday. Up to you, sir. Sir, I'm done.
Okay. Thank you, Dr. Dash. I think now it is very clear to all of you what is the meaning of the model, why we are talking about the model. And the two things are there. One is the test data, another one is the training data. So this is the training data. And after that, you have to validate the model with the test data. Okay. Do you have any questions, students? Hamida madam has joined. Hello, Hamida madam.
Hello, sir.
Yeah,
So
you are late, but I think you have understood in time.
yeah, yes, thank you, Dr. Ivan. It's a very clear explanation. So I was wondering, sometimes we see like backward or forward regression. So there, we want to keep something even if it is not significant, not to come out from the model automatically, force it to remain in the model. So is that necessary, or like say for example age and sex, while I am willing to see the cognition, that's the outcome. So I want to keep the age and sex, even if it is not significant. Is that what we should do, or we shouldn't keep whatever is not, because automatically the model is taking it out. So whether we should go with that, or like we force it in. Uh, I want, from like literature, it has been shown that okay, age and sex might have impact on cognition, but the model is showing no, it is not. But even though, is it a right thing to keep it?
No. For this, I must answer you in this fashion, that if you need to basically put it there, if it has to be there, then you go by the enter method only. Whenever you are going by the forward or the backward method, you are giving software the privilege, the freedom to decide on its own. However, if you have strong literature review going on that these two will be working very good, you can input it in the enter method. Okay. Otherwise, another option is that I would like to do over here. If I were in your place, I would maybe try to separate it out. I mean, run it with the age and sex, because I know strong literature background is there. Run a separate model, and with the ones that are unknown to you, you can run a separate multiple model. And but however, if you say that, sir, I want to include everything in a model, I want to show how they are working in a family, then I must say there is no option for SPSS to, put either forward or backward and then specify that this will be remaining anyhow. This provision is not there.
Okay, thank you.
Welcome.
Dr. Dash, whether the dummy variable can be used in logistic regression?
Dummy coded variable only that I have shown you, sir. This kind of gender, it is basically dummy coded to 1 and 2. Age is basically dummy coded to 1 and 2. That is what I believe you are saying, the nominal ones, the nominal variables.
So all the males will be 1, all the females will be
Yes.
0,
yes,
like that.
Yes. In SPSS, you can use the auto decode option. SPSS will do the auto decode automatically. So in this fashion, like you said, sir, all male are 1, all female are 2, or if you have more, then it will be 3. Like this, the dummy coding happens, and you can input it accordingly in SPSS.
Okay. Okay, thank you, Dr. Ivan Das, for giving your valuable time to enlighten our students. We are very much hopeful that our students can perform the logistic regression in their own research. So we will meet again on Monday for the multinomial regression at the same time. So dear students, please be present during that time.
Sure, sir.
Thank
Thank
you
you, Dr.
all.
Das. Thank you, Dr.
Thank you.
Das. It was
Very
very,
welcome.
thank you.
Okay, sir. Then
Okay, thank you. Thank you,
Okay.
Dr. Das. Thank you.
All right, sir.
Thank you,
Thank you
Dr.
very
Das.
much. You're welcome, ma'am. You're welcome.